Okay, so good morning. Thank you everybody for being here. We are with Mathieu Virbel. He's a freelance developer. He will tell us all the secrets of the Kivy framework. Thank you, Mathieu.
Thank you. Thank you. So hello again, everyone. So who I am. I am working. Well, okay. I am working in Melty. Maybe it's too loud. Yeah. I created a company that are doing only freelance work, and I'm working like on daily basis on Android, iOS, some multi-touch screen, projection screen. I'm working for museum, for education, for businesses. And originally, I was not a developer. I was a web developer. I work also in a security. I was a sysadmin, a security admin. So I know quite a lot of platforms and a lot of things, a lot of language, etc. So today I will focus on Kivy and a lot of tools around it. So it will not be a talk only on Kivy. So before telling anything about it, I will just show you what we are doing from my company or from other company is doing with Kivy. So it's a tiny video, 1 minute video. So the very first thing you will see is a menu of a restaurant on an iPad. It's done by Thomas & Son in America. Here you have a multi-touch table for exploration of minerals. You have another application when you can take picture and put some things onto you. You have an interactive room, so with Kinect and help disabled people. You have a museum exploration, some other content with Kinect exploration. And another things I've done is kaleidoscope with 4 tablets and 1 computer. And Thomas did a paint application. Also another exploration of content in a museum in Iowa. And you have a quiz on the iPad as well. And the very last thing is exploring the word's content, the word's meaning with gestures. So I will get back on the application we are doing with Kivy after. Just wanted to show you what kind of application we are doing with it. Okay, so that's it. Is Kivy? How many of you have heard about Kivy already? Okay, less people. So maybe you are not the audience intended to use Kivy. I mean, we are doing a toolkit, but it's not usable for every kind of project. So like here for museum is fitting perfectly because on museum you need to be able to switch from one ID to another very easily, always test. In these setups, we have a multi-touch screen with a map of a city, of the models you are seeing. Like here, it's very tiny. The model is like 2 meters to 1. So you have a screen with the model. You can touch the screen, and the model will be highlighted from where you touch. You have information out of it, like you touch a building, what is it, what is a related building to it. And you have also Panda 3D integrated into Kivy. So you have the 3D view of what you are touching. So everything is in Kivy except the 3D. And it allows us to switch to one ID. Like, OK, we test it on the model. And I don't know, the color is not working, the widget or the placement is not working. We want to change it in live, like in front of everybody. And we can do it easily. I will just do a live demo, and you will see how easy it is. Another kind of application is one I did last year. It's for education. Here is the next version of the application. You are exploring the word meaning with gesture. Like if you take a car you will scale up, like everybody knows a scale gesture, and the car will be a truck. And if you scale down, it can be a bike. You can have the contrary of the word. If it's a verb, you can conjugate in the past with 2 fingers, in the futures. So the idea is, with very few words, you can just assemble them. So it makes the kids like exploring the world and trying to see the relation between the words. Also, it can be for games, like 2D games. This is one I did in 16 hours, just for like checking what I will be able to do with Kivy. We can do also business application. I already shown that one like 2 years ago. It's a business application like for making diagrams. And the last version so you're modeling all your diagram, your processes on the tablet or on your desktop, and you are able to deploy it on activity and execute it. So this is the kind of things we are doing. If you intend to do like web application, like if you come from the web world and you want, I don't know, a map widget, a Google map widget, we don't have, and we will not have, just because Google Maps is HTML, JavaScript, and even WebGL, but all the components they give will not fit in OpenGL. So it's not gonna to happen any soon. But we will have a map widget where you can use Bing, you can use OpenStreetMap. So we have alternative to it. If you want to have an OpenGL application, but with web content, like a pure HTML rendering, we don't have also, because this is not our target. If you want to do HTML stuff, just use another toolkit with HTML. We are close to native application and super fast. That's it. So let's talk a little bit about the organization. Kivy is only the project, but we are an organization of 7 people around the world who are committing regularly on the project and on a lot of projects. We manage more than 18 public projects right now, I guess. We have 2 mailing lists for contact us. Use Kivy Dev only if you are working on one of our projects, not if you are working only on your application. And we have an IRC channel where a lot of people are here every day to help you in your issues. Okay, let's talk about Kivy. As I said, Kivy is only the UI part. The next slide will show you, or we can use widget, etc. with it. But to be able to run the UI on mobiles, you need more things. So we are managing 2 toolchains. The toolchain is how you compile Python for Android or Python for iOS. Means Python is running natively on your on your computer, but if you want to put it on the phone, you need to recompile it for ERM, mostly. Android have no more target available, but we support only ARM for Android. So that's it. We are managing 2 more projects for that. We also manage tools that will help you to package your application into Android on iOS. I will talk also about that. And because we are Python, it's hard to access to Java API. Like you want notification, you want accelerometer from Python. But if you look at the Android API, everything is in Java. So how do you do the bridge between your Python code to the Java? Before, we was writing like a lot of code. You need a Java class, or you need to have a GNI file that will do the wrapper between Java and C, and then you need to write a Python extension that will use the GNI code you just wrote. And then, from the Python, you are able to access to Java. It's like super complicated, and I never get any contribution out of it. So this is not how we tackle the issues after. We was thinking about another way to do it. So I will introduce PyGenius for the one who don't know about it, and PyObjGS. That is the same for accessing to Objective-C. Okay, so I don't know if some of you have already heard about some of our tools. Like I did a talk in PyCon US, and we tackle Kivy in the wrong way. Like we talk a lot about what he is able to do without showing any code and without showing really what we are doing. So I will do the inverse way. Like I will talk about the Kivy widget. I will talk how you can use it, and I will introduce more features of the toolkit with concrete examples. I hope you will stay awake with it. So because it's a new UI, it's comparable to GTK and Qt. We have a lot of widgets, like labels, button, checkbox, etc. So very simple widget you can use. We have a little bit more complex widget, like a text input, because we need to manage only one line or multiple line, password in text. We have also a code input with coloration syntax. We have some layouts. Then you can assemble your widget. We have complex widget, means the complex one, we assemble the simple one in order to make a complex one. So it's less customizable. And from the last EuroPython, we was asking to do something about managing multiple screens and having transition between one screen to another. So we did that last year. And we have one widget named scatter. The scatter have all the logic about the pinch, the rotation, and the zoom. So that's it. Let's see in real what we have. Okay. Everybody seeing? Yes. The colors are wrong, but still. This is one example we have within the toolkit. It's called the showcase. Not all the widgets are here, but you can see like it's looking a little bit like the Android team. So we have buttons, slider, text, etc. We have some complex widget. Even with accordion, you can put content. It will be fit automatically. We have a file chooser, two different kind of file chooser. Actually, it's abstract, and you can create your own view out of it. We have a scatter. So as I say, I am on a MacBook. Actually, the trackpad is, you can use it as a multi-touch thing, but it doesn't really work if the way Kivy is working, because it doesn't match what you see. The trackpad is more usable if you do gesture. But if you want to just do a scale up, scale down on a specific widget, you don't know really where you need to put your finger on the trackpad. So it's deactivated by default, and we activate only the mouse bar, so only one pointer. We are multi-touch toolkit, so how can you do to test multi-touch things if you don't have the hardware? Thing is, by default, Kivy have a multi-touch simulator in it. So with only one finger, here, I'm moving it, but if I'm doing a right click, I will have a little red dot. So it's a yellow dot for you. And it's like I'm still touching. And then I will touch another part of it. And my touch, the first one is not moving. So I can test a very simple multi-touch things with it. Can even try with 3. Up. Okay, I have like kind of 3. So you might think it doesn't really work with 3, but I assure you, if you test on a screen or on a multi-touch table, you will not do like weird stuff with your 3 fingers. You will more, I mean, when I look at people 3-4 years ago, when I was building multi-touch table, we wasn't able to handle more than 2 fingers on the scatter. The thing is, try to say to all the public, like, if you want to zoom your widget, you need only to put 2 fingers like this. Okay, so the public doesn't really understand what that does. what is natural is just to put the end and do the scale like that. So that is why we implement more than 2 finger. And just another issues with it that unfortunately we cannot handle is when you are using a multi-touch screen, it doesn't really happen on the phone, on tablet. But you might wear some, I don't know the word in English, like un pull for the French people. There is French people here? Sweat? Sweater jumper? Okay. Un pull, yes. Okay, a jumper. So when you wear a jumper, sometimes it can touch also the touch screen. So the public is trying to scale up, but they don't see that their jumper is just touching the screen. It's not working, so you need to go up. It's like a mess. But anyway, that is a scatter, and I just put an image in it. But I can put also other widget. So here I can move. I have my button. My button is working even if I apply a transformation to it. Okay. And I can even, it's hard to do it myself, but somebody can even move the scatter and someone else can play with it. It's like we don't have focus. If one event is dispatched across the toolkit, it will not block all the other widgets. They are all working together because all the widgets are made for multi-touch at the start. It's not like GTK and Qt because they are not doing the same event dispatching as us. All right. So how does it work? This is a very simple hello world, the same as we have on the website. Here you will just import the application class named apps. You will import a button from the UIX modules which contain all the widgets. You will create your own class, subclass in app, and then you need to instantiate to subclass a build function. And in this build function, you need to return at least your root widget, the widget that will be displayed in your windows. Just creating a button, setting a text hello, and making the font size a little bit bigger. I will explain what is DP for the one who don't know about it. And then I will instantiate the application and run it. Very simple. This is my Hello World application. So I can click on it, but it doesn't do anything. Let's add something to it. So I will create a new property named count, and I set to 0, and I will bind the onPress event of the button, and when the event is called, it will call the increment callback. For every kind of event, we always pass the source of the events. Here means you can bind multiple buttons to the same method, to the same callback, and you will know the origin, the source of the events, because it will be the first argument of your methods. So inside the method, I will just increment counts and update the text of the button with the counts. Okay? So I'm clicking on it, 1, 2, 3. Okay? Let's go further. Here, just creating an assembling widget. So a very simple box layout, and I will add 3 widgets in it, a button, a switch, and another button. A button, a switch that I can, on, off, or I can just click on it if I don't want to do the gesture, but both are working. And another button. I can even set few properties to the box layout if I want to add some padding and spacing. So here again, let's see the difference. Difference is the padding is around the box layout. The spacing is between the children of the box layouts. Okay. There is few more seats if you want, like there is 10 seats here. And a very last example of how we can assemble this widget is a carousel. And here I will just grab all the images of my directory and put it into a carousel. Up. So that's it. And the carousel, I need to do the gesture like I need to click and move, and I will move to one images to another. And because I set loop to true, when I will get to the last image, it will come to the first one. I cannot back to the left direction, only the right direction, because I force it to it. So everybody understood? Very easy? Okay. Next things is the properties. In the last example, I was using Python properties, is like self.count. But the thing is, what if I want to watch what is going on the count? Like maybe the count can be incremented or changing from a lot of part of my application. I don't really know where, okay? But what I want to do is to be able to watch what is going on the count, and when it's changing, change my UI in the same, in real time. Python doesn't give you anything about it. I mean, you could overload get attribute if you want to look on the specific attribute, and then you can look at the assignation, not get attribute, set attribute, sorry. But it's like it will be the same for every time you will try to assign something to your classes, it will call this method. So it's not going to be very performant. And also, what if you want to do value checking, like to be sure that the 0 will be -1, or I don't know. So we wanted to have more control about the properties. So that's it. The first things we did with the properties is to be able to observe what is the change of it and attach a Python method or a function to it. As I said, we wanted to have value checking. So we have many different properties, like string properties, numeric properties, option properties, like orientation of a box layout. It's an option property. You can set only horizontal or vertical. If you try to set something else, it will raise an exception. So you can design your own widget with that kind of properties. We also have some error handlers, like, the value checking here is, I think it's obvious, like it's 0 is the default value, and I don't want my value to be under 500 or -500 to 500. If it's going out of the bounds, it will raise an exception, but sometimes it is not what you want. You just want, okay, if the user made an error when he was playing with the application, I will just put another default value. So this is what error handler are. Is here, if I'm setting like 100, 1,000, yes, 1,000 values, it will just go to the error case and will assign 0 instead of the user value. Or you can create your own handler on the fly to try to set another value. That's it. So how you can use it? Very simple. You import a numeric property here from the property modules. You need to declare the property in the class, not in the constructor of the class, not in another function. It needs to be at the class level. The numeric property class, as all the other property class, is implementing the Python descriptor. So I will not go into it, but just to know that if you put the declaration somewhere else, nothing will work. And because we have the default value in the constructor here of the numeric property, you don't even need to assign. Okay? So there is no need to declare here. It's already declared before. I'm creating the button, I'm binding my callback to it, and I'm returning the button as a root widget. And in the callback, I will just increment the count to 1. All right, let's test. I'm clicking, yes. The numeric property is correctly incrementing, but I don't update the UI from the change of my property. So I need to bind to it. That's the next step. The next step is here. Self is the instance of the class, right? Okay, I will bind every change of count property I will call update widgets. And in update widget, I can update a lot of other widgets. Here I will just update my button text as before. So the result of it will be exactly the same as the previous application, but using our properties. Okay? Properties, everything is okay with that? Because now we are going to the real issue, no, not the real features of Kivy, is the Kivy language. I know that lots of people who are going into Kivy doesn't really look at the documentation and doesn't really learn what's the Kivy language. They are almost lost about all the magic we are doing behind it. But why are we doing another language? What is motivation? The motivation is create UI very easily, like you have a main screen with a logging, settings, kit button. Sometimes you want to change the padding, you want to change the images between it. I don't know. When you try to do it in Qt on GTK, or even in Python with Kivy, it's like a lot of code to be able to do that. And if in case of you try to just add a layout and put free button in it, you will write even more code in Python. And it's very hard to see actually what is my widget tree of all the single line I have in my Python. I want to see exactly what is it. So that's one of the motivation. And the other motivation is like I was showing to you. I click on the button, the text of the button chain, and everything is using the count property. What if I just want to have a label and a slider, moving the slider, changing the text of the label? I need a way to easily connect components between them. So this is why we started another language. And the language has three types of construction. The first one is the Kivy rules. It's like a CSS for an HTML tag. So you will write the rule in Kivy, and it will match one Python class to it. So when you will instantiate the Python class, we will apply the rule to the class. We have another construction is named the root widget. I will not show you to it, but it's like if you want to create your widget in live, an instance of your widget, you can use that construction. And the last one is the dynamic classes. I will go into it just after. So this is not Kivy language. This is only the Python part of your application, exactly the same as before. But in the build function, instead of returning directly a button or a box layout, etc., I have here created what I call a main UI. That's a class box layout. Okay, and I'm returning it. If I'm trying to execute the application, it will be black. A box layout doesn't have any rendering things. Okay? By default, every application you are doing, like here, I have named my application Demo Kivy. The application class will try to find a file named demokivy.kivy in the same directory of your application. And if it finds it, it will automatically load it. What is in, in the Kivy files, what do you have? First, you have a declaration line. So this, in English, dash and colons? No. Is it what? Okay. Hash and colons, right? Yeah, hash colons. It's like a special directive for the Kivy language. So here we are just checking that the Kivy version is at least 1.1. Then I will create a rules for my main UI widgets. Inside the rule, I can set directly properties. So a box layout have orientation. I will just set my orientation is horizontal. I can create widgets on the fly and add it into the main UI. So I'm creating a label here. And the text of the label, I will also set it. And there is something interesting is here. App is a special keyword that represents the current running application. And so I'm accessing to the property of the application. So do you feel it like when the property will change, the expression, Python expression, will be automatically evaluated again, and the text will change of my label. And I can add another widget, like a button. And here, I will create an handler on the fly. So when I'm pressing the button, I will again increment the counter. All right? Let's see. So I have label button. I'm pressing the button. The label is changing. Very simple. So that's the language. The language is doing a lot of things. First, we have few reserved keywords, like self, root, app, self. Oh, whoop. Not really used. Okay. Like here, in this expression, if I put self, it will reference the label. So if I'm putting self here, in that line, it will reference the main UI. In the label, if I'm using root, it will always represent the top widget of your rule. So it will be always here, the main UI instance. Or we have the last keyword, reserved keyword is app, that will be your current running application. And so we are doing dynamic inspection of everything you are putting into the language. I think it's obvious, but I will tell it again, is the left side here is a Kivy property. It can't be a Python property. And the right side is a Python expression that we inspect. And we are automatically trying to find couple of a word dot another word, maybe dot another word, dot another word. When we found it, we try to resolve it like, what is it exactly? Is it just a method? It is a property. Oh, it's a property. Does it have a bind function? It has it. Okay, so this part of the expression have a bind function. Oh, this part of the expression have a bind function. Okay, I will just take the whole expression, create a callback, and automatically bind X and width into that callback. Means if one of them is changing, the expression will be evaluated again and assigned to X of my labels. All right? And we have few optimization. Like, if you don't have any dynamic thing in your rules, it will be like static. So we just eval once, and we store, we don't execute the expression anymore after. So we can do some nice trick. Like, my menu is a box layout. I can change the orientation of the layout depending on the size of the ratio of my widget. Like, my widget is Y, or I don't know, the other way, but you understand it. So I can change the orientation. And I can also, like, remove the button. I was saying, like, put a slider. I can slide it. And I will assign an ID. An ID will be only usable within a rule. It will not be extended into another rule that you can do, that you can have. And so in the label, instead of using app.con, I will just the value of my slider. So I will add a slider. I will move the slider. My text is changing on the fly. All right? Okay. Another part of the Kivy language is the dynamic class. Like, sometimes when you are designing your UI, you want a widget that we don't have. We give the tools for you. I mean, the widget is simple. and we don't accept all the features you want to have in our widget, because otherwise we will have a very big classes that we will not able to maintain and test all the case. Instead, we give you the possibility to assemble and create your own widget very easily, even on the flies. Like my idea of the numbered slider is here. The naming is wrong, but I wanted to just have the value of the slider in top of the bottom of the slider. Okay, I have a rule here, the name, arrobas, and then this is a subclass I want to inherit of it. The slider have a rules also inside Kivy. So the rules of the slider will be applied first, then the one here will be applied after. So in the slider, we are creating some graphics, some things, etc. And here I will add, in top of that, a label. The label, we just use the root value, the slider value. I'm putting in font size. And here, there is already something interesting, like what is texture size? So I didn't do any slide about it, but I will explain a little bit. Like all the widgets in Kivy have a bounding box. A bounding box is like you have a position and a size. We never constrain the graphic into the bounding box. It's up to you. You can draw a little bit outside the bounding box. I mean, it's just a way to position the widget, but you need to take care of it. Labels, images, camera, video, all these kind of widgets manage a texture. When you are putting some text, you need to render the text into a texture and display it on the screen. That's the same for the other widget. So instead of binding the of forcing the size of the widget to the size of the texture, like if you writing hello world, the texture will be like very wide, but the label might have a bigger bounding box. So you always need to juggle between two things, like the bounding box of the widget and the texture. Here, I want one thing. I want my label width to be the width of my texture. So it will be fit, the bounding box, I mean, for the width, will fit to my texture. And I will just try to put it at the right position here. Root, again, is a slider. Value pose is a property of slider. How can I say? The slider can be from 0 to 100 if it's 50. Okay, 50, but where is it in pixel on my screen? Value pose with compute automatically the position in pixels. We have also another thing is value normalize. I will show you after. Is like whatever is your bounds, your minimum of your or your maximum of the slider, it will compute a value between 0 and 1, and it's very easy to use it and making fancy stuff. Okay, that's it. And how can I use that new classes? Because I didn't declare it in Python. I just declare it on the fly in Kivy. So there is two ways to use it. First, Kivy language will already know about it because you declared just before. So I'm just using it as any other widget, and I can assign value, assign properties to it. And this is all the slider properties. Okay, there is it. I have the label changing just up to the slider button. Okay? And I didn't wrote a slide also about it, but if you were in Python, all the widgets are registered into a factory. So you can just say factory dot the name of your widget, whatever it is. It can be declared on a class, it can be declared in the Kivy language. It just works, and you will be able to instantiate it on the fly. And also the factory is supporting lazy loading. Like you can register a name and said, okay, the implementation of the name, like the numbered slider, if it was a Python file, I can say factory.register, numbered slider, comma, and my class is I don't know, my application.widget.numbered slider. So it will load the module only when you will use really the widgets. So we don't load everything at the start, only what you need. Next step, the graphics. Doesn't seem obvious, but everything you see, we have graphics. And because we are running on desktop and mobiles, we need to have a common place to do the graphics. So everything you see is going on top of OpenGLES. If you want really know more about how it's working internally, you can look at my talk in the last year, because I have done a talk only about GL and GLES and the difference about it, and why it's very, very complex to use OpenGLES. Like, even if you want to render one rectangle, you need to have a lot of initialization and a lot of question just for drawing one rectangle. But Kivy's have a wrapper around it. Nick talked about it in a lightning talk. It's like we have few instructions that do the work for you, so you can use it. And if we are missing something, then you need to go into OpenGLES, and good luck. We are able to do a lot of things. Last year, we wasn't able to do any 3D graphics. Like, all the graphics engine was only in 2D. Like, we think about only a UI, not really big stuff like in 3D. But we work in it. We add the possibility to change the vertex format to be able to add the Z, and you can even add a lot of, it's really customizable. So you can create your own with, vertex format and use it. So now we can do some 3D stuff. I'm sure you remember if you were at the lightning talk yesterday, but that is the example of Kivy. So if you go to the example directory, you have it. OpenGLES 2 doesn't have direct rendering. You always need to write a shader. The default shader of the one we are writing is very simple, and with handle texture, vertex, etc. So, but you can write your own shaders. So, if you know how shader works, you can do that kind of things. Or because because all the widgets are rendering into a shader, you can also change the shader on the fly and doing some interesting effects. Like, it doesn't look like that. This is the default shader. So I have a scatter with an images, and I have a button. I can change the fragment shader. But I still have my widget, and I can continue to change it. Yeah, it doesn't. Yeah, we don't see the button. Projector sucks. Okay, you can say we don't care about it. Like, it's not useful for us. All right, maybe, but you can do like weird rendering or ever black and white rendering. We don't use it, but we could use it. Like, when a pop-up or a model view is coming on the screen, we could just make all the widgets behind it like in black and white, so the user will like have more focus on what you want to show. And when the pop-up will close, we will just put the color back with a nice transition. So that's perfectly possible to do it with Kivy. You have the full control of the pipeline. And because it's heavy, we wrote all the graphics part in Python. And I will not go into it, but we try to reduce as much as possible the impact on the GPU. Because even if a GPU can be performant, like on a mobile, you need to try to lower the number of instructions into it, otherwise it will not be fast. So we have some logic around it. And that's all. So let's see how it's working. Again, if you want to know some Python code on graphics, just check the thousands of examples. Here I will focus on the Kivy language and show you that it's really easy to add graphics into it. So this is my numbered slider that I just wrote before. But there is one thing I didn't show you, and this is on the slide, is the minus bar. What is the minus bar on the rule? It's like, I want to have a slider with my own graphics, and I don't want the previous rule applied to it, like Kivy teams have wrote graphics for it, but I don't want it. I just want my own representation out of it. So if I'm putting minus in front of it, it will not execute all the previous rule. So it's like you still have the Python part working, but nothing is shown. I will manipulate the canvas of the slider. Canvas is a canvas instruction. It doesn't know anything about the position, the size, or the bounding box about the widget. It's just a place where you can put your instruction, your graphics instruction into it. I will put a color instruction and set it to red. I will add a rectangle instruction and saying, okay, the position of the rectangle will be the position of, oh, wait, self. But I was saying self was the instant of the widget. You're right, it's the instance of the widget, not the graphic instruction. You cannot make graphic instruction depending of each other, okay? You need to do, you can't do it, and we won't do it, because we have a lot of optimization around it, and it will just break what we are trying to achieve. So I will not go into the detail, but that's it. Self, you will never be able to have the instance of a graphic instruction. Self will represent the widget. What is the widget in my thing is numbered slider. So the rectangle will be at the position of my slider, and I will change the size, the width, according to the value, but the normalized value between 0 and 1. Okay? Let's see. Oh, big. Okay, so my rectangle is really moving. It's a red one, you see, good projector. Okay, one step further. A little bit more complex. I want to have a slider, but if we back on the first slide, it's like, okay, what is the size of my slider? I was saying like every widget have a bounding box. And the bounding box is like here. I didn't talk about layout, and I will not talk about layouts, but when you put a root widget into the windows, the size of the widget will fit to the windows. All right. So if I put a slider, the bounding box of the slider will be the size of my windows. And I want to say, okay, the white bar, the 8 bar, I want to set it myself. I don't want to use the Windows, the parent 8. And I will force the 8 of my slider to be 48 dp. And I will add more instruction. The first bar is the same as before. I will just change the color. And because it's the same position inside, it will just look like a background of my slider. Then I change the color again. And I will play a little bit with the value normalized to change from green to red. And I will add another rectangle on top of it. Let's see. This is my slider, and I can change it. Depending the value, it will change the color. Okay? So what I'm showing is if you want your own widget, you can do it. You can use the simple one we made, and you can create your own graphics. So if you are doing a game, if you are doing any kind of application, just don't ask us to make a new team or another team in top of the widget, because we don't really know what you are exactly wanted into widget. Just make your own. And it's, as you see, it's very, very easy to do it. I mean, I think it's easy. You agreed or you don't agree? No? Yes? Not sure. I think it's, okay, if I do a quick poll, like how many of you think this kind of representation is easier for the developer just to change the construction instead of writing a lot of Python code? Okay. Okay, so don't go in Python, all right? Because when I see bug reports that use only Python, it's like a mess to read it. And recently, I refactored one example named the compass. And the guys, it was a contribution. He wrote like a very big example about it. And it wasn't working. And I just rewrote it. Like the Python code is like tiny, and the Kivy part is tiny. It really helps you to have more concise and precise code. So just go into it. So I will go one step further. Like, OK, this is word rectangle. I want to use images. The rectangle instruction, you can set the texture, a real OpenGL texture to it. Or you can just say what is the source, what kind of image I want to put in it. OK, but look, like, it's not a PNG. It's not a JPEG. What is atlases? In Kivy, we have atlases. Like, if you have a lot of texture into your application, and if you put a lot of widgets that use different texture, basically you will break the OpenGL pipeline because you will always change from one texture to another, one texture to another. And this is what we call breaking the pipeline, breaking the context. It's possible with Kivy to have only one texture, as much as possible. So you bind like one texture at the start and draw your UI. So no more context change. To be able to bind only one texture, you need to create an atlases. So you can put all the images into one directory, and we have a command line that you can just execute it. And it will assemble all the PNG and JPEG into one texture that you can reference. This is an atlas. And the default theme of Kivy is an atlases. OK, just to show. All right. Oh, just to be sure, this is the cursor of the slider. By changing the slider, OK, it's looked very weird. I think there is a better way to do the graphics here. The button is like a circle, but I could be able to stretch it in the right way. So how many of you knows about the border image in CSS3? OK, some of you. Well, we have it in Kivy. So we have border image instruction with a border things. What is a border? It's like here you will say, on my images, the 24 pixel at the top will be fixed. OK, I don't want to be stretched. Same for the right, bottom, and left. Everything inside the border will be stretched. All right? And I didn't change anything else. It is. OK? So the border are not stretched, only the middle are stretched. So it means you can have very small graphics and just making cool stuff out of it. Let me show you one thing also. It's like, let's go to the Kivy. 20 minutes. Where is it? Kivy. Tools. We have timing. Default theme. Yes. So this is like all the PNG that is used inside Kivy. They have a name, etc. OK? And this is what the generated atlas is looking. Data, images, default theme. OK, there it is. So all the PNG used by Kivy is only in one texture. And we'll create a JSON where we just name it atlas. And it contains like all the ID, all the file name in it with the position and the size inside the texture. Just wanted to show you. So I will not go into the input part. Like, it's multi-touch. You can trust me. I will show you the demo just after. And we can use a lot of different things. I wanted to show you my lip motion. I'm sure some of you know what is it. And it's working with Kivy because they was very kind. They sent us two devices, one for Thomas and one for me, to do the integration into Kivy. So you can manipulate your interface with it. I didn't got time to just use it in the presentation. So we are able to play with the Kinect. We are able to send a touch event from one device to another. So if you are doing your touch table with camera tracking, like Kivy is not doing any image tracking to check where the touch is, but there is several other tools. Even one we wrote called Move It. It will send so it will find the touch and send it into OSC, and Kivy is able to read OSC. We have core providers. You don't really care about it, but when you load images, when you render text, when you load a video, etc., depending on the platform, we might use a different provider. Like on desktop, we are using JStreamer for video, but we didn't been able to use it on Android. So we compile FFmpeg, and so we switch between one to another. That's the same for images. Pygame is able everywhere except on iOS. So we can swap from one dependency to another. And if we want to support a new platform, most of the time, if we are not able to use an existing provider, it's really easy to write a new one and to support, yes, another dependency. So that's it. With Kivy, you can develop ONS on your desktop and run it almost everywhere. But I didn't show you how to run it on Android and iOS. You know why? Because it wasn't easy at the start. And this is how I'm introducing the toolchain. Oh, I will just skip it. Oh, no, a lot more. Yes. A little bit about metrics. Metric is like, if you put some font size or width in pixels, pixels is not the same if you are running on an high density screen or a medium density or on your desktop on Retina. So the size will always change and it will be not good. If you want a size that depends on the DPI of the screen, you can use PT, mm, or SM, centimeters. All the free one is using the DPI. But it's still not good, because when you are on a high-density screen, if you write text exactly the same size, like if I write a 1 centimeter text and I put the same on my phone, the thing is, because the screen is more accurate and have more density, it will just look so big, and you are not used to see big fonts on your small screens. So we have, the same as Android, is scale-independent pixel and device-independent pixels. So it's SP and DP, and you will put value, and depending on the device, the real size will change. But it aims to have the same feelings across the device. So if you put a size in DP, whatever you are using, the desktop or the mobile or a tablet, it will just look okay. All right, but the real size will change. We have also modules when we can simulate the DPI or inspect anything. Like, okay, another demo. Demo showcase. So I was showing the showcase. You have the inspector. If you type a Control E, okay, I can inspect anything like the button, slider. I will click on the slider. I have all the property in it. I can check. Can even change, like, I don't know, the value. Okay, I will put 90. All right. And just for the fun, it's not committed, but I will. But I'm not really using it. It's because we are in 3D. Whoops. Okay, I don't know what's happened. Because we are in 3D, I just created for fun a 3D inspector. So like, I can just activate it and see all my UI in 3D. So it can be just fun to see the layer, like how many widgets you use to be able just to place a widget. But it's like, I'm not able to inspect anything right now, but I'm sure that the next things, like the Kivy designer, will be able to use it. All right. Just wanted to show. Okay. Okay, I need to go further. Python for Android. Python for Android is a toolchain that is able to compile Python to ERM. The initial goal was to make easier the compilation on Android. I think we get it, but the user didn't get it, and we lack of some documentation. But I work a lot into it, and I think the very last documentation of the website is good. So you need to tell me about it. Python needs to be compiled to ERM, but also other things. OK, 10 minutes. Like if you have a Python extension, it will just not work. You need also to compile to ERM. So the toolchain is doing that for you. But not all the Python extension is working. Sometimes you need to fix the extension in order to be able to compile it on ERM. And then when you compile everything, you can use a build.py script that will just grab your source code, grab all the toolchain, and make an APK that you can deploy on your phone. It's not easy to install Python for Android. It means you need to install all the SDK and NDK. You need to have build tools available for it. You need to have a good Python version. And you need to export a lot of variables, like where you put your SDK, NDK, what API you want to use, what NDK version are you using. And you need also to have the Android tools into your path. It can be complex, but once you've done that, you clone Python for Android, you go into it, and you call a script that is named distribute.sh, and you put the modules you want. I need to put Kivy, because Python for Android is, we try to use it also not only for Kivy. I know there is P-side team who are trying to put Qt into Python for Android. So with the same toolchain, you will be able to do a Kivy application or a Qt application. There is also another guys who work on a minimal version of Android, like not OpenGL, not everything. You just want to have Python runs your Python, Python code, you running your simple Python script. So no Kivy, nothing fancy. Distribute can be long, like depending on your hardware, because it's compiled a lot of stuff. You can have error because you miss a step before, but if everything is correctly installed, it just works. Then you package your application. Because I only 10 minutes, I will not package that application in live, but it's very easy. It's not really easy. You need to call build.py. You give a name to your application. You need a package name. It's like an ID. This is the ID where the phone look at when you want to install or deinstall an application. This is also the ID that will be used in the Play Store or the App Store. But it's not for Python for Android. You put a version, and you put where your code is. OK, but I give a directory. What file name I need to, what is the main file? So you need to have a main.py file into the directory. And then we are doing all the work. Like we are creating the OpenGL contents and start your main.py file on Android. Once you have that, the debug, here I want to create a debug APK, like no fancy signing. But I can't release a debug things. I need to put release if I want to create a release version of my application. And then I need to use the Android tool to be able to sign it. Then I can just share the APK to everybody and even upload it on the Play Store. And you can install on the device and do a logcat into it, so you will have the logs. We have limitation, as I was saying, like pure Python module cannot be used in Python for Android. That's not, it's a toolchain. It's made for compilation. If you have pure Python module, what you can do is just install them and copy into your application and change the syspath in order to include it. So it sucks, but this is all we do right now. And we have some recipes to compile a few modules. So this is, maybe you are interested about LXML, we have it. Maybe you are interested into 0MQ, we're working on it. And we have the same thing for Kivy for iOS. all right, you compile the toolchain, but instead of building your application, Xcode is doing that for you. So we create an Xcode project, and all you have to do is just to open Xcode with the project, press play with the device connected, it will work. We don't support the simulators right now because it requires a double compilation, like one for your device and one for your desktop. So we have tried to work on it and failed right now. So I hope that one day we will be able to support both. So that was Android and iOS toolchain. But to be honest, I don't like it because it's hard to manage. And I want a tool that does everything for me. I mean, it can be better. I don't want to care about the dependency. I don't want to care about the package name. And why should I change the Xcode project and maintain also a command line for Python, for Android, etc.? So I think it can make the work for me. This is why we created Buildozer. Buildozer will manage everything for you. At least I think it will manage. It's not another packaging system. We have a specification files, so you put your title, your version, where the source code is, what kind of permission you need to have, etc. Even for the version number, we introspect the main.py file. So if we see a version tag, we just use it, etc. So it's a specification files, and on top of that, when you launch Buildozer, it will install everything is needed for the platform. So if you target Android, it will install the NDK, SDK, Cython. If you target iOS, it will install also the things needed for iOS. It will compile everything. It will also install the pure Python module into a virtual env. Okay. If you are trying to install a Python extension, it will fail. It means it's a limitation, and we cannot use the toolchain for it. As I explained, you need to write a recipe because sometimes not sometimes, all the times, you need to fix the Python extension in order to be able to compile it on ERM. And then the virtual env is compiled into your application. Yes, and we patch the main.py for you in order to include the pure Python module you just wanted to have. And it will create the APK and IPA automatically. So that's all the steps I showed you before. Buildozer is doing it for you. But it's doing more than that. It can also deploy on your connected device. And if you have multiple devices, it can deploy on all of them. You can even automatically run the application on it and even have the log of my device into my console. So here, I need to take 1 minute at least for the demo time. Let's say, do I have it? Yes. Everybody is seeing it? Where is it? OK. So I'm targeting Android, -v just to have more messages. I create a debug package. I will deploy to my phone and run it. And in order, OK. Ah, fuck. Sorry. Yes. OK. I will just use my phone. All right. So let's see. Buildozer. I'm running it. It's doing everything. And because I don't have internet here, I'm running on a local Wi-Fi, thanks to the EuroPython team for giving me an AP, a Wi-Fi AP. So I don't have internet. I just compile everything before coming to the conference. So all it needs to do is seeing that everything is compiled. All it needs to do is to package it. OK, so here we are. The deploying is happening. He's trying to install it. Success. He's running it. And screen sharing sucks again. No, wait. You need to see this. Okay, that's it. Because I will run out of time and I'm talking too much, I will not be able to introduce you PyGenius, but at least I want to show you something. It's like a very little application for taking pictures. So it's a Kivy application, but when you want to take a picture out of your camera, you need to access to the Android API. So I have done it, so I can just press take picture, and the screen is already broke. No, okay. No, the screen is broke. Sorry, guys. It was working this morning. Like we tested yesterday, we tested this morning, but of course the demo is not working. But here, I can take a picture. So the Kivy application is going into the background. And here is an Android application just for taking picture. I will take the picture, or right here. Same thing. OK. And then I put the picture into a scatter, so I'm able to reuse it into Kivy and doing also fancy stuff. Okay, that's all. But sorry for the screen sharing. And so that's it. This is Bulldozer, all right? And so big things. Okay, how many times do I have? 2 minutes. 2 minutes.
Less. 1.
Okay, perfect. Perfect. PyGenius. PyGenius is a project just to access to the Java class from Python. So I hate Java. But unfortunately, I did the work for you. So I hope you will use it and you will thank me about it, because it was a real pain. And PyGenius, it just uses the Java reflection. I can introspect the Java classes to know, OK, it's returning a string, so I will return for you a Python string. Or the methods need an integer, it needs a byte array. Oh, OK, you pass a list with numbers. I will convert it into the right byte array in Java. So we do the reflection. It's like in live, and you can use it in live. So here it is. This is one example. I will just have a class around the local thing, the local Java class. I will have a Python class around the Python activity and the text-to-speech. And this is a little demo just for saying hello world. That I can show you in live, even without the screen, because we have, we have an application that's named Kivy Remote Shell. What it does is give you a SSH access into your application, into the remote shell. So again, it's just a screen, and it's saying to me that I need to go SSH minus admin. Is the Wi-Fi? Yes, the Wi-Fi works. Password is Kivy, but you can try. I'm not on the same network as you. Okay, let's see. I will just grab the text. So this is the real things, like, oh yes, the Wi-Fi doesn't work. Okay, so I imported PyGenius, autoclass it, and then let's see. I will create a Java text-to-speech object and saying hello worlds. Oh, I was a little bit too fast. Yes, 1. Wait. The sound was obviously muted.
Hello world.
Okay, everywhere?
Hello.
Okay. I have the same version in Italian, but OK. That's it. And we can do also implement Java class into Python. Like, you cannot implement abstract classes, but all the Java interfaces, you can implement it. So here I will just implement a listener from the location listener in Android. And every time Android will try to call the on-location changing of the interface, it will call my Python function. So I'm able to have the GPS things on Python. OK, can do a demo on it. And because sometimes it can be very hard to write things like that, we started a project named Plier. And Plier, we will have a simple interface and implement everything for you for all the platform, like notification. You want just to notify something to the user with a title messages. So the notification part is working on my MacBook. It can work on Android, on iOS, etc. Okay, and it's using behind the scene PyGenius and PyUbiGeos. We have Google Summer of Code running on right now with 2 students. One is working on the Kivy designer. We was aiming on GSOC last year, and he failed to make a good Kivy designer. Like, nothing was working. It was a real mess. And not nothing was working. It was working, but the code was a real mess, and we cannot just show it to you. So we started to accept a new student for that. And my student, Ivan, is actually working on PyUbiGeos. That is the same thing for PyGenius, but for Objective-C. So the demo I show you, you will be able to do it also with your iPad or your iPhone very soon. I hope at the end of the Google Summer of Code. We got funded. The PSF granted us $5,000 to make the Python 3 port, and it's already working in master. So if you just clone Kivy and use it for the Python 3.3, it just works now. So thank you, the PSF, for that. We tried to do some crowdfunding. So I asked $600 to run Kivy on the Raspberry Pi because a lot of users were trying to do it. And I got funded in 5 days, so that was amazing. And I tried to get a little bit more of money because the works needed for the Raspberry Pi could be used to improve the Windows version. So this is the next step, is to do a POC to use Angle. And just very fast, Angle is a project by Google, Mozilla, and I don't remember the other one, is to be able to translate OpenGL into DirectX, because Windows, OpenGL support on Windows really sucks, but DirectX is working. So Angle project is doing that. You would say, well, what's a mess? Like OpenGL to DirectX, who want to use that? Chrome is using it. Like all the WebGL stuff, it's translated in live to DirectX. So in Chromium and Chrome. That's it. We want to use it also. And thank you to everybody. And a special thank to Ashke and Gabriel, who are looking right now the talk in IRC. Both guys did an amazing work into welcoming everybody that just introduced Kivy. So they are working a lot on the mailing list and doing a lot of fancy stuff. So I want to thank them, because without them, I will not be able to do everything I'm doing. Okay, and we have a sprint on Saturday and Sunday. So if you want to try to make an application, help us to have a better documentation, etc., just come. That's it.
Hi there. Thanks for a great talk. I just had one question on your slides. When you were doing the demos, was your demo actually launching the program directly, or did you have 1,000 windows open?
No, it's running into Flask. So I just have an AJAX, a request from jQuery, and I'm asking to execute my example when I click on it.
Just a question
Yeah.
about the texture atlas.
Yes.
You show us before. If you have a really big project with maybe a video game, a lot of sprites,
Yeah.
etc., you will have an atlas with a texture, a really big texture, I guess.
Yeah.
You know that GPU and have an hard limit on texture size.
Absolutely.
Okay, how can you handle multi-platform here?
Actually, we don't support. It's up to you to generate the right texture. I know it can be a pain, but OpenGL has I think it's 248 pixels minimums. So if you generate your atlases with that minimum size, it should work everywhere.
Okay, thank you very much.
Hello, thank you for the talk. It was really, really interesting. I have a few questions. Could you point me to books on Kivy?
There is no books, but come to me. There is somebody who is currently writing tutorials about Kivy, and he was at PyCon and is going to write a book. And Ashke and Gabriel also is going to wrote a book. I don't know where is the status about it, but it's in the process.
And the other question is, I tried a few of the demo applications that you have for Android, and I found that first of all, the sizes of those apps is compared to other applications is huge. Plus the startup time it takes quite a while for the application to start up. Are you addressing that in one of the next releases?
Absolutely. So one thing we cannot really reduce is like Java application use all the component that is already installed into your system. You are doing a Python application. Unfortunately, Python is not compiled and installed on your system, so we have nothing to rely. So we need to include binaries of Python into it, and we need to include all the py file, but we are doing it as small as we can. And about the startup time and the size time, I worked about an ugly way, it's very ugly, to be able to reduce the startup time to be the same as any other startup time. It's in a branch, it's working for me and in a few people, but because it's very ugly, I can explain to you how I did. I'm afraid about merging into master for everybody, all right? But the thing is, I think a Kivy application, like the very simple example without nothing fancy, it's 6.6 megabytes. It can be heavy, but we have a blacklist, so you can edit the blacklist and add few more Python module into it. Like if you don't use encoding, you can just put all the encoding you are not using into it. So you can reduce it almost to 6 megabytes, maybe 5.5 is the maximum I have been able to do it with blacklist. And with the branch, I have been able to reduce it even more, but it will never be 1 or 2 megabytes. Like, it's not possible.
And the final question is there any way to test Kivy applications? Simulate the button presses and the movements of your fingers?
You mean on the device or anywhere?
Just anywhere, just to be able to write unit tests for your application.
So we have a few modules. One of them is the recording module. So you can just record your touches and replay it after. Okay. I never tested on Android, anyway. But on Android, you have ADB input tap, and you put the coordinate so you can simulate touch or swipe.
Okay, thank you.
That's it.
You're making a UI and you're comparing it to Qt and GTK. Do you have accessible names for all these widgets that you build? Like if you have a label, does it give an accessible name of label and its text to TalkBack or VoiceOver or any of these built-in screen readers that these devices have?
Nope.
And no plans or?
No plans, no. Yes. Unfortunately, as I say, we are only a very small team, and even if we have more and more people involved into it, it's very hard to compete with people like Qt. They are huge, and a lot of companies are behind them. And I wish that Kivy could have the same audience as them, but we need resources to be able to focus on that.
Okay, so thank you for your presentation. So I'm a 2D game engineer developer from Japan. Okay. So generally we use GUI tools game developing. For example, particle editor and asset manager, toolchain and sprite animation builder and so on.
Repeat the question because with the door I didn't hear you.
Sorry?
I didn't hear you with the door closing. So
sorry. Okay. So generally, we use GUI tools for game developing.
Yeah.
So for example, particular data and so on tools. So I have a question about their tools. So do you have a plan that Kivy project to provide user developer with GUI tools?
I'm not sure I understood the question.
Oh, sorry. And
Can,
do Kivy project have a plan that Kivy project to provide some GUI tools, for example, particle data and sprite animation builder, and so on, to
I'm sorry. Maybe because I'm tired, but
I'm sorry for my poor English.
So you were saying, like, do we have some tools for particle things, or?
Yes, particle editor.
Yes.
And map editor or level editor.
No.
No. Okay.
It was an idea for the GSOC, like making Kivy more useful for games and having more default widgets or tools for it. But no student got into it. But Chaos Buffalo Labs is a company in US where I think they are doing an RPG with Kivy, and one of the needs was to have a particle engine into it. They wrote one, and they also did an application for editing the particles. So this is one you can find actually on the Play Store. It's called Particle Panda, and it's done everything in Kivy. So you can adjust the particle. It will export a text files that you can use it in the Kivy particle engine. But it's a separated project maintained by them, not us. And for the other tools right now, no, we have no plan for that. But you can come to the sprint, and we can start something out of it.
I will go to your place.
Perfect. Okay. So thank you, everybody.
Yep. Thank you very much.